working on here, but I'm going to also write a lot of stuff on the board as well. There's probably about four major components to, four sections we have to deal with in terms of naming compounds. And to go from simpler, so the first one was the simplest situation, dealing with the elements that have a very predictable charge when they go into an ionic compound. And so that's what I tried to do here and on the next slide. This slide and the next slide. So these are the things, and I had a student ask me, are we going to be given these on the test? No, I am expecting you, this is why we're focusing so much on this. My expectation is that you will work with this and practice this enough that you'll know it. You will know it. There is some things you have to memorize. If we were in a Spanish class and it was your first time you're taking Spanish, they'd say, well, we're going to start learning kind of how this language works, but here's 100 words that really, really useful words. You should try to get these in your vocabulary. Okay? You get them in your vocabulary, you can use them in different sentences, and pretty soon you kind of know how to ask someone where the bathroom is or whatever, okay? Well, what I'm saying, get these into your vocabulary. There's not 100 of them. Look at here, group 1A, they're all +1. Right away, what do we have? We have 7. 7 right there that we know right away are almost always +1. Alkaline earth, 6 more of them right here, +2. Aluminum is +3. Silver is +1. Now you see silver is the only one in this region. We're going to get to this region before we're done today. But we got this one here because it is predictable. Almost always forms a +1 ion. The halogens, -1. Oxygen and sulfur, -2. Nitrogen and phosphorus, -3. You with me? Okay, so we've already covered this. This is review. And this is that. This slide and that slide are about essentially the same. There's group 1, group 2, group 3, and silver. So that's the first thing. What are the elements that are predictable? All right, and you can see, I could stand here at the board and write ionic compounds till we got bored of it. Hundreds and hundreds and hundreds of them. So I'm not suggesting to you that you memorize the name of compounds and their formulas. In some cases, there might be a few things like that, like sulfuric acid. You might need to memorize that formula, but in general, what I'm saying is learn this way of determining what the formula is based on the charges. That's where we're going. And then you'll see you can do just about, you can get the formula from the name, or you can get the name from the formula. We looked at this. Here's piecing the names together. And those are all very predictable ions here. These are all on those slides right there. Sodium oxide, Na2O. All right, let's pause there for a second and write a few. My red marker going. There it is. So let's do aluminum. Aluminum sulfide. I'm starting out with a hard one. Let's do something like sodium sulfide. Look at that. Go to write sodium. And I write the symbol. Sodium sulfide. So the formula for sodium sulfide. So find the symbol that corresponds to these elements. So right from your periodic table, it's like what I was starting to do, sodium, Na. Sulfide is sulfur as an ion. That's the sulfur ion. Next, what are their standard charges? Sodium is what? Sulfide is what? -2. And then what we introduced earlier is now you just cross these numbers. This 2 is going to go right in here. This 1 is going to go right in here. Na2S. And the 1 is understood. Doesn't need to be written. So we get the formula Na2S, sodium sulfide. This is the system. And the formula for a compound is always going to be overall neutral, even though it is comprised of positive and negative ions. The overall net charge on this thing is going to be neutral. So you could prove to yourself that it is just by working off these charges again. 2 positive 1 ions gives us a positive 2, and 1 negative 2 ion, we only have 1 sulfur here, gives us a negative 2. That's the total positive, total negative charge represented in that formula. And the sum of those is 0. This is what I mean by neutral. Overall net 0 charge on that formula. And every one of the formulas that we write today should kind of work out that way. All right, so let's do aluminum sulfide. Aluminum. So we get the symbol for aluminum. We get the symbol for sulfide. We get the charges. And we cross those charges. We put a 2 here and a 3 right here. We get Al2S3. That's aluminum sulfide. And to just go through that charge accounting one more time, we have 2 plus 3 ions here for a total of a plus 6 positive charge represented there. We have 3 negative 2 ions there for a overall negative 6 negative charge, and that corresponds, the sum, arithmetic sum of that is 0. The positives are balanced out perfectly by the negatives. Let's look at this. Let's just stick with these simple ones for a little bit. Magnesium oxide. Magnesium oxide. So a lot of these I'm going to pick up just to kind of make it point. A little subtle point as we go along here. We get our symbols, magnesium oxide. Plus 2, minus 2. And if we cross the charges, we're going to end up with something like this. But what can we do with that formula? We've got Mg2O2. How can we simplify that formula? each by 2, why would we do that? If I divide each of these by 2, I'm ending up with 1s, Mg1O1. In here we had a 2-to-2 ratio, which is the same as a 1-to-1 ratio. And just to make the point that what we are interested here is in that's what we are interested in. What is the ratio of magnesium to oxide ions in this magnesium oxide compound? What is the ratio of those ions? Because we are talking about ionic compounds. Now I'm going to, hopefully before we end today, I might mention a little bit about covalent compounds, and we're going to see things might pan out a little bit differently there. Let's see if I can find this slide. Just remember that these ionic compounds are not, yeah, there we go. I think these ionic compounds are not molecules. They are big crystals. So salt is a crystal that has a 1-to-1 ratio of sodium to chloride ions. So I mean, it would be just as accurate to say it is NaCl as to say that it's Na10,000 to Cl10,000, or a million to a million, or a billion to a billion, but whatever it is, it really comes down to that bottom line. No matter how tiny or how big of a chunk of salt you have that ratio, a 1-to-1 ratio, sodium and chloride ions. You follow me? And just, we'll get to it with molecular compounds, but that's not what we're doing when we write this formula, H2O. We are actually saying, we've got a molecular substance here, and it has 2 hydrogens attached to 1 oxygen. It's not in a big crystal like this, unless it's an ice cube. But if it's the water vapor that was floating around in San Antonio today, it was floating around in H2O molecules. And there ended up being so many floating around that they decided to stop doing that. All of a sudden, boom! And they came down as liquid. But that's a molecular substance. Everything I'm talking about right here are ionic. So we'll get over here eventually. But let's really get ionics under our belt. Okay, any questions? You follow me? Okay, so now let's should have kept track of what slide I'd been on. Okay, I was just right above that. All right, so now that segues us into the second area to understand are these polyatomic ions. Polyatomic ions. I cannot go get a bottle of this stuff. I can't go get a bottle of carbonate. I can go get a bottle or nitrate. I can go get a bottle of silver nitrate. Silver nitrate. And I can't vouch for the fact that the hospitals still do this. I think they do, though. I think they do. When a newborn baby is born, moments after the baby's born, they drop a drop of silver nitrate in each eye. Silver nitrate in the eye. Why? Well, for any kind of sexually transmitted disease or any disease that could be transmitted from the child, from the mother to the child. Remember, the child inside the mother, their blood systems have not, they have not commingled. In the placenta, the mother's blood or the baby's blood. Those are separate. So that baby is in its own little antiseptic world. And then at birth is where the baby is first exposed to any kind of outside bacteria. And so right after the birth, they'll put a few drops of silver nitrate in the eye, and it kills those kinds of bacteria. The baby hasn't really ingested anything yet, but the epithelial layer of the eyes is a way in which bacteria can infect. So they put a drop of silver nitrate. So here's nitrate. Let's see if we can make that a little bit bigger. Yeah. Now keep in mind there are cations and anions here. But we'll focus in on these cations. Excuse me, anions, negatively charged ions. So what you need to know, and you need to commit these to memory, that nitrate is an NO3 with a -1 charge. You need to know all three of those things. Its name, the correct formula for nitrate, NO3, and the correct charge on it. Whenever you see a nitrate, that's what you're looking at right there. It's always going to be a -1 charge. These are well behaved. These aren't going to have different charges. I mean, they do have different charges, but sulfate is always going to be -2, hydroxide -1, cyanide -1, phosphate -3, carbonate -2, bicarbonate -1, and acetate. There are many more of these. There's nitrite and sulfite. And don't get this confused with this. Okay, a little spelling change, and you're talking about two different ions. This is the sulfide ion, and this is the sulfate ion, SO4 with a -2 charge. So let's come down here. We've got a silver. Did you know that Argentina was named after silver? That's where it got its name. Those who explored Argentina or landed on Argentina, they were looking for silver. I don't know if they found a lot of it. They must have found some of it to name the place Argentina. But they were naming it after this element, silver. And then nitrate. And this has a +1 charge. This has a -1 charge. So, there's going to be a 1 and a 1. And so that is the formula. This is silver nitrate. Silver nitrate. So let's look at barium nitrate. Barium nitrate. The nitrate hasn't changed. Got a -1 charge. Barium, Ba, it has a +2 charge. How did I get that so fast? How do you figure that out? What's barium got? Where is it? It's group 2A. It's an alkaline earth element. So also, if you want, one thing you will have in front of you, I mean, like I said, you're going to need to know these, but you don't need to memorize that barium happens to be a group 2A element. You're going to have this in front of you at the exam. So getting really familiar with this will be very beneficial to you. So there's barium right there. So it's an alkaline earth element, so it's a +2 charge. All right, now I'm going to get this 2 over here. We're going to get a 1 there. What do I need to do with this? Put it in parentheses. 2 right there. All right, that is just completely confusing and wrong. We don't have BAN with 32 oxygens around it. We have a barium ion with 2 nitrates. So what we really are looking at, we need 2 of these, and the way we do that is we bunch it together in parentheses. We have BaNO3. Okay, now you try this one. Keep our aluminum right there. I'll write 2 of them up here. We'll do aluminum carbonate and do aluminum phosphate. All right, so go ahead and do those on your paper. Aluminum carbonate, aluminum phosphate. This helps me to just kind of see how you're catching this. Good. All right. So we've got aluminum here. We've got a carbonate. This is a +3. This is a -2. So the 2 is going to come in here, and the 3 is going to, we're going to put the carbonate in parentheses and put a 3 there. It's aluminum carbonate. And there's a +6 charge here, and there's a -6 charge represented here, and it's neutral. Aluminum carbonate. I mean, this is a very common anion. It's in our drinking water. We have calcium carbonate and magnesium carbonate, about 150 parts per million of that in our drinking water, because the water has percolated down through the sandstone and saturated it. So it's got dissolved as much calcium carbonate in it as it can dissolve. And so that's what makes the water hard. Doesn't have aluminum carbonate. Might have a little bit of it, but hopefully not too much. But calcium and magnesium carbonate. Okay, now this one is a little bit interesting, because what we have here is a +3 ion in the aluminum, and phosphate right here is a -3 ion. And so we would have Al3PO4 but that's 3 to 3 or 1 to 1. So that is the correct formula for aluminum phosphate. We want to get it down to the lowest, the simplest ratio of positive and negative ions. I put calcium acetate up here because we kind of we ignore this one too much. Acetate. It says it's also CH3COO minus, but in ionic compounds, you will usually see it represented this way. If you go to organic chemistry, you'll see it represented that way. But notice they're the same. Two carbons, three hydrogens, and two oxygens, and a negative charge. So it's just a different way of writing it. It's nothing else, but this is the way you'll normally see it in a formula for an ionic compound. This is a -1 charge, a +2 charge. So in this case, we need to wrap parentheses around that and put this 2 outside that whole thing. So we have calcium acetate. All right. So the simple predictable charges, that's number 1. Number 2, your polyatomic ions. Maybe the other one we're ignoring here right now is ammonium. This is a really common ion right here. So we've been doing names to formulas. Let's just do formulas to names. Well, what would you call that? What would you call that? Yeah. What you got to do is recognize that that is a polyatomic ion, the ammonium ion, and you've got to represent it or recognize that that is a polyatomic anion, the hydroxide ion. So that's all we're doing is we're just naming these 2 ions. Ammonium hydroxide. Write the formula for, now notice the similarity here in name, ammonium versus aluminum, but they are distinctly different, okay? Don't get ammonium and aluminum mixed up. When I say some of these things, all I'm doing is telling you the mistakes that I have seen so many times. All right. So keep those separate. Keep sulfide separate from sulfate. Really do learn what they are. Let's leave that one up there. Write the formula for aluminum, look at that, did it? Ammonium sulfate. Ammonium sulfate. So what is that going to be? Oh, parentheses? Okay, ammonium sulfate. Sulfate ion is a -2 ion. The ammonium ion is a +1 ion. Here is an ionic compound that's made up of polyatomic ions. The positive ion is ammonium. The negative ion is a sulfate ion. Yeah, so recognize what you're being faced with. Okay, third and last area, I think, for ionics is these elements here in the middle. What's going on in here? And then the fourth one would be covalent or molecular compounds. How do we name those? But let's go on to keep in mind that I told you the group 1A, group 2A, the halogens, predictable charges. When we get on into here now, we're entering an area where the metals in there do not have predictable charges. They can have more than one charge. Sodium is always going to be +1, but iron can be +2 or +3. So that's what we're dealing with here. Let's deal with one aspect of this at a time. Iron can be +2 or +3. If I say, what's the formula for magnesium chloride? Magnesium chloride, we write that because this is always +2. But if I say iron chloride, if you say that to a chemist, the chemist will say, which iron chloride are you talking about? It isn't, this is ambiguous. Can't just say this. I can say magnesium chloride, and there's no ambiguity. All magnesium chloride is MgCl2. But iron chloride comes in two varieties. It comes in the +2 variety and the +3 variety. And so what we do to take that ambiguity out is we put Roman numerals right here. And just keep in mind that that Roman numeral is not telling you how many irons are in the formula. It's telling you the charge that's on the iron. Okay? So don't get that mixed up. Don't think that iron 2, that means there's 2 irons. No. So that's iron 2, so let's put iron 3 over here. So we've got an iron 3, so we say iron 3 chloride. So what that is telling me is that this is an Fe+2 ion. Chloride is always what? What's the charge on chloride? What? -1. See, this is telling me that, which goes here. So I get an FeCl2 for iron 2 chloride. And here is a +3 iron. And so the 3 goes here, and I get an FeCl3. That's iron 3 chloride. What hasn't changed here is we're using the same methodology that we've been using right along. Our prompt is what is the charge of the ions, and we've been swapping those numbers and getting the formulas. So nothing's changed there. It's just that when I write this as an ion, I don't know which ion you're talking about. Now, just an example, just to give you an example of where, this is the way iron is. You know your red blood cells, hemoglobin, have iron at the center of them. And it is +2 iron. That's the iron that's in your red blood cells. It can get bumped up to an Fe+3 under certain situations. But the ideal place, and the reason it's in there, this is the charge that's on that iron in hemoglobin. I was just reading over the weekend about a condition where you can get met hemoglobin, MET hemoglobin, which is hemoglobin where the iron has been bumped up to this +3 charge, and that's not the normal or desirable charge for it. Okay, so it does matter. It is real. It's real. You can see iron. If we went over there, if we went across the hall and got a bottle of iron chloride, I think it would be yellow, and this would be a different color. They'll react differently with things. So they are distinctly different compounds. This has 1 iron for every 2 chlorides. This has 1 iron for every 3 chlorides. Okay. So there's only 3 elements here that I'm going to, there's 20 elements that I could talk about that do this. Chromium and cobalt and nickel and a whole bunch of different, mercury. But the 3 I want you to really commit to memory and be familiar with is iron, copper, and tin. Iron, copper, and tin. And notice in here that this also discusses a stock or systematic nomenclature. The systematic nomenclature has to do with Roman numerals. That's the systematic. And what it doesn't matter what element we're talking about, the Roman numeral 1 means +1. All right, this is the Roman numeral 4, 5, and 6. I'm not sure I've seen anything besides 6. But, yeah, I mean, you could go on up from there. But the Roman numeral is referring to a number, and it would be the positive, that number, or, yeah, it's usually, they're using Roman numerals. But before they established this, these elements also had a common name. And notice here, this iron 2 was referred to as ferrous. So this right here would be the +2 iron, ferrous chloride. Oh, did I erase the other one? Oh, shoot. I put it there specifically. Hang on to it. Iron 3 chloride is also referred to as ferric. All right, so pay attention to these prefixes here. What they mean, what OUS means, is that it is the lower charge of the 2 charges this element can acquire, a +2. The ferrous is the 2. Ferric is the higher charge, the +3. Copper can be a +1 or a copper +2. Okay, so copper doesn't get a +2, +3, it's a +1 or +2. So this would be copper 1 chloride, for example. And this you could have a compound of copper 2 chloride. This is going to be CuCl2. This is going to be CuCl. Okay, copper is +1, +2, so the lower charge would be called cuprous. notice that this ick, this +2 copper, we're not going to call it cupris like we call the iron 2. We're going to move that one down here because that's the lower copper charge. All right, I think there's one more slide after this. Yeah, right here. Same slide, but it includes the tin. And notice the tin can form a +2 ion or a +4 ion. So the lower one, +2, is stannous, and the higher one, +4, is stannic. Stannic. Now what I've given you so far now, with this is the third arena here, transition metals. We're over here in transition metals. Is, enough to go out and name 10,000 ionic compounds. That's a great rainy day activity, actually. I want to give a couple examples here now. Let's see. All right, here's what we got to do. So, name this compound. Let's say I write so name that compound. Give me the name of that compound. Fe parentheses NO3 3. What charge is on that iron? What is it, Eloy? Eloy. What? Eloy. I got it right. Look at Eloy. +3. Okay. So you're working backwards from the formula to a charge, right? I said we'd go from a charge down to here, so you're moving this up to here. That's one way of doing it. It tells us that's a +3 charge. The other way is, that's a -1. We know that too, right? 3 of those is going to contribute a -3 to this formula. And so that means this has to be +3. Both ways gets us the same place, however you want to do it. So now, what should we name that? Ferric nitrate. What's another name for it? What's another name for it? Iron 3 nitrate. Okay? And partial credit is iron nitrate. Maybe partial credit. It's the online exam. It would be wrong. Iron nitrate would be wrong. It's just not the complete name. It just doesn't nail it. What iron nitrate are you talking about? One of these names does nail it. On your Chapter 3 homework in Connect, you might find, I'd have to kind of dig around in there to look at it more carefully, but I do suspect you will see questions that say, what is the stock name of this compound? In which case that is the answer. Okay? Or what is the common name? Probably something like that. Let's let's see, write the formula for what's the formula for ferrous phosphate? Ferrous phosphate. Okay. Ferrous is the +2 ion. Phosphate, -3 ion. And if you cross these, get the formula, ferrous phosphate. Okay. This is a practice worksheet. We'll do a couple now, and you can pursue this to the extent you want. I'll get you started on it, and then I'll take attendance, and I also want to pull up these practice quizzes that are online. Show you. Practice, practice, practice. This is what will get you to memorizing and being real comfortable with these different species and their charges. Did everybody get one? Okay, place to start would be right here. This work on this one. They're really having you kind of, you got some blanks in there. Shows you an example across the top. Ariana, Claudia, Sydney, Angelique, Christelle, Nick is here, Melissa, Maurice, yep, Eloy, Josette, Tiffany, B, Juliana, Joseph, Carolina, Brianna, Jennifer, Leanne, Peyton, Samuel, Jonathan. Jonathan here. Cody, where's Cody? And Alex. Alex is here. Okay. Okay, did anybody get to number 7? We down there yet? No? Okay. Usually have this turned off. Yeah, this chart is giving you some practice both ways. Going from a name to a formula, name on the right to a formula on the left, or going from a formula to figure out the name. And you can see of all the examples we did, I think those are all except for sodium chloride, non-examples we did. All right, why don't we just give me some of these, just the formulas. So number 1, what is the formula for number 1? Okay. No, let me just some subtle little things. Cobalt, you can see cobalt there is CO. So you do have to be careful with uppercase and lowercase letters. That is cobalt. That's carbon monoxide. Okay? A capital O is oxygen. Just a C is carbon. So cobalt, here's calcium. So capital, lowercase, at least in the formulas, you got to pay attention to this. Magnesium nitride, what do you get? Someone else. All right, magnesium nitride. And that's going to be add up to a neutral formula. Potassium ion is the +1 and the sulfide -2. So what's the formula for that going to be? Potassium sulfide. All right, ZNO is, what's the charge on that zinc? That's zinc. What would the charge be on the zinc ion in ZNO? +2. How do you figure that out? From the oxygen. You know it has to be neutral. This is neutral, and this is a -2, so that has to be a +2. So zinc oxide. Tin 4 oxide. Tin 4, so there's our first time we're experiencing a +4 charged ion. Symbol is SN. I guess I should do SN. What's the rest of the formula? O. Would that be right? This would be minus 8. Yeah, it's just SnO2. SnO2. Because then that gets us to a negative 4 right here. All right? That balances out this plus 410. SnO2. Okay, and Cr2, what do we got? Cr2S3. Okay, now, we've not done anything with Cr. There's Cr right there. Got your periodic table, you find that's chromium. That's a heavy metal. It's a toxic heavy metal. Chrome-plated stuff makes it look shiny, makes it look like silver, but it's a toxic heavy metal. So here is an unknown. You've never seen chromium before. You don't know anything about chromium, but you do know something about sulfide. So, always don't ignore what you know. So that's a -2 ion. So that's going to get you a total of a -6 charge. So these two chromiums are going to be a +6 charge. So we really got 2 times x, 2 times x equals +6, right? And the math, each chromium is going to have a +3 charge on it. Now, you also don't have any way of knowing whether it can have another charge, but it can. So really if you named it chromium sulfide, you might not be, blamed for that, but this is actually chromium 3 sulfide. Now, chromium 3 sulfide. It's not one of the 3 I had you memorize, iron, tin, or copper, but we've figured out it's got a +3 charge on it. It is a transition metal. They don't all do this, but a lot of them do have more than one charge. Copper phosphide. So this, they gave us this. Copper phosphide, what would you have for that? How many coppers? Did I hear 3? 3. Cu3P. So copper phosphide. All right. Here's what I wanted to show you. If you go to your Canvas course, go to quizzes, and if you come down here, see, here's some practice quizzes. Practice naming compounds, practice writing formulas. So let's we'll click on practice naming compounds, and I could say I want to take the quiz, or I just want to preview the quiz here. And you can see it's going to give me 20 questions. And look at that first question right there, AlC2H3O2. Let's just, let me just submit this. I got 20, so I got a 0 because I didn't answer anything. It's going to come up here and say you got a 0. let me preview it again and see what happens. I get 20 more questions, but you see the very first question is different. All right, I don't know that you will get 20 different questions every time, but what I'm trying to tell you, you can take this quiz as many times as you want to. And if you take it and you get a 10, then you need to take it again. If you get a 10 out of 20, take it until you get about an 18 out of 20. And these will be sitting here even up into the exam. So you go into the final exam and you say, well, I'm going to take that quiz some more. So let's okay, let's do this one. Number 7. Look at question number 7. What is the name of the following ionic compound? Name that for me. I'm going to type it in. We're going to submit the quiz and see how we did. And then what I'm going to do is go over to I'm going to go over to Connect and pick up Chapter 3 homework, and we'll see if we can do a question in there. What's the answer to this? Lithium, and I'm going to put a space in there, bicarbonate. Lithium bicarbonate. And then I'm going to go say submit. It's going to say, did you know you left 19 questions unanswered? I'm going to say, yeah, I did know that. And I got 1 out of 20. You did. See, they're all wrong except lithium bicarbonate. And it's actually saying there's 2 possible correct answers there. Lithium bicarbonate or lithium hydrogen carbonate. Okay, let's go down here. I'll go back to quizzes quickly. I said I wanted to go to Connect. I don't know if I'll go back to quizzes. And I tried this earlier and I had a little problem, but let me try it. Writing formulas. So now I'm going to come in here. I couldn't type anything in earlier. So iron 3 carbonate. What is that? Well, ammonium hydroxide. Let's see if they'll let me type this in. So ammonium hydroxide is going to be NH4. Now, it's not going to be easy to put subscripts in here, so just put the number right next to it. Let's do that one, and I want to find one where I need to use parentheses. Here we go. Iron 3 nitrate. Let me just do this real quickly. Fe, parenthesis, no spaces, NO3, parenthesis, 3. Can you see that? Is that big enough for you to see? All right, so now let's submit this and see if we got those 2 right. So we got iron 3 nitrate, we got ammonium hydroxide in there. So we should get 2 out of 20. 2 out of 20. So I like that, okay? All right, so you don't need to hunt for subscripts. Just put them in. Just know that if you were writing this on a quiz or something like that, I'd like to see the subscripts. That this isn't the normal way of doing it. We're just doing that. Okay, now let's see if I can get back to the home page. Oh, the McGraw-Hill Connect. Let's see if I can get. We're all done. We're down to time here. Chapter 3 homework. How can I do the preview? Preview the homework. So here's where I'm kind of doing the homework. Be sure, identify the correct Lewis electron dot structure for the following atoms. Beryllium has 2 electrons on it. Boron has 3 electrons on it. Fluorine has 7. Right there. And sulfur has 6. Right there. See if I got that right. Check my work. I got it. Okay? So, 40 questions. Question 20. What does that look like? Probably I'll come up one. The formatting is so crazy. Click the answer box to activate the palette. Uh-oh. Write the formula for the following monoatomic ion, the platinum 4 ion. So I want to P. Click the answer box. Let's try that one. Oh, not that one. Which one do I want, folks? That one? That doesn't look right.
I usually just right key and then I click the arrow and then
You do what?
delete that.
Delete.
Yeah, press trash can.
Trash can.
Now type in your letter and use your arrow key to hit the arrow key to like on your keyboard. Now you can just press erase.
Hit the arrow key.
Yeah, and then click that little first plus the subscript.
What is it? Platinum 4. So we need a plus 4, or do they want 4 plus?
They usually do 4 plus.
Okay, all right.
They're very technical on entering it.
Okay, check my work.
All together, they'll count it.
Oh, it doesn't like that. The 4 plus needs to be up in there. Okay. All right. That's why I give you 2 attempts.
We already did that homework.
You-
It was due last night. Chapter 3 homework quiz.
You did. Everybody did? Wait a minute. Okay, I know I'm keeping you here. Chapter 3 homework. You're right. I got the grades right here. 2 people didn't do it. No, we're all right. Everybody did it. Did you do the quiz? Was that due last night? Well, what are you going to do all week if you did these 2? All right, do this. Do this, do those practice quizzes. Geez, I thought I was helping you out. You've already did it. I can't get ahead of you guys.
I know that's what I was like, I
Okay.
was gonna say the makeup for the homework one, I believe. I tried sending you a message about it. I didn't
Your
like,
name is what?
Joseph.
What? Just that?
Joseph Gracie. And I think
Sats?
it was homework one. Yeah, I didn't really even like try doing the makeup one.
You couldn't do the makeup one?
Yeah, I messaged you about it, and it just kind of showed like a blue screen again, so I didn't know if they were still having trouble with it, or that's the only one I wasn't able to do.
Okay, well, hang on here. Let's go back here. Let's get rid of that. Let's go back here. Stand up all day. Melissa, you have a quick question?
I just wanted to remind you that my math assessment's still not in the grades. So my grades still like really.
Okay. Let me just look. There it is. Yeah. All right. Okay, I will get that in there right away. Okay, now, what do I need to do? I need to go here, and I need to go. This is chapter 1 homework,
Yeah, I think.
Oh, and
it
there's
was
a chapter
it
one
was
makeup.
Yeah, the makeup. I was
and
going to do
that closed the 22nd.
Yeah, I tried doing it on the Friday. Like I tried doing it before
Yeah.
it closed, and I tried messaging you about it too, like right before, like the day of.
Okay.
I
What are we
just
gonna
didn't
do
know if
about
there
all
was
this?
another alternative.
Yeah, I don't know. Well, let me get that makeup and see if there is an alternative. assignment results. And I want to go to set.
That's so weird.
I touched something the wrong way here. I touched something I didn't want to touch. Let's go to there and let's see if we can manage date. Let's see if it will let me extension for you. Do. Twenty-ninth. Let's see if it'll let me do this. Increase the number of attempts. Why does it want me to? Okay, I'll increase the number of attempts. Looks like it did something. Try it again.
And then just let you know.
Yeah, and let me know.
Oh, if anything, I'll let you know by next class. That's when I was open.
Okay, okay.
Thank you.
You're welcome.